Hey gang, so now we're on geometric sequences. Basically the only difference is now we're going to be multiplying, you know, that common difference. Now we're going to have a ratio. So I've given you this sequence, 16, 18, 4, 2, and 1. And so I want you to look, and you're like, okay, there's not a common difference. The difference here is 8, the difference here is 4, the difference here is 2, the difference here is 1. So there's not a common difference. So then you start looking and you say, did I multiply by anything? And you're like, well, it's kind of like you're dividing every number in half. Or I could say that I multiply by 1 over 2. 1 over 2 times 16 would give me 8. 1 over 2 times 8 would give me 4. And so it's like I'm multiplying by 1/2. Kind of like saying dividing, but with geometric, we're always multiplying. So it's not arithmetic, it is geometric. We multiply by 1/2 each time. That's how we get the next term. So instead of having a common difference, we're going to have what's called a common ratio. And luckily for us, ratio is going to be R. Here's how we're going to write it. R equals U sub n. Now let's think about what U sub n is. That's just whichever term you're on. And remember, we talked about this many times. If this one right here is U sub n, if this one right here is U sub n, the one before it would be U sub n minus 1, and the one on the other side would be U sub n plus 1. The common ratio is take U sub n and divide it by the term before it, U sub n minus 1. That's how you get the common ratio. Take the term, look behind it, and that's the term you divide by. In this particular one, the common ratio would be 8 divided by the term before it, which is 16, which is 1/2. Okay. So let's see if we can do an example here. Let me give you -2, 6, -18, 54. Right off the bat, I hope you're like, wait. How can it be negative, positive, negative, positive? That's because if your common ratio is negative, every other one would be a negative. If you see negative, positive, negative, you know it's geometric. Or at least you know it can't be arithmetic. This wouldn't work. Hopefully it's geometric. Okay, so let's talk about that common ratio. We're going to take U sub n and divide it by the term in front of it. So we're going to take 6 and divide it by -2. It looks like they are multiplying by -3. So R equals -3. Okay, so let's put some words down here. Okay, what is I should have given you this here. What is a geometric sequence? What's the definition? It is a sequence where each term is found by multiplying the previous term by a constant called the common ratio. And that is R. Okay, what about a geometric series? You know what? It's going to be the same thing. It's going to be where we take U sub 1 plus U sub 2 plus U sub 3 all the way out to U sub n. Same thing. Geometric series is when we sum up everything. Okay, here's your rules for this. S sub n equals. It is going to be U sub 1 times the ratio to the nth, whatever power you're trying to find, minus 1 divided by R minus 1. That's the first one. That's the one I tend to use the most. Or, and this one's interesting, U sub 1 times 1 minus R to the nth power over 1 minus R. Now, which one do you use when? You know what? You just kind of play around with them and see how it works. All right, U sub 1 equals the first term. I don't have like a good rhyme or reason, I tend to always use the first one, and it tends to always work out. R equals the common ratio. Okay. So let's take a sequence. Let's take this one right here. -2, 6, -18, 54. And let's sum up the first 8 terms. Okay, what's the sum of the first 8 terms? So let's use this first one here. So we're going to say U1 is -2 times the common ratio. Did we find the common ratio? It was -3, right? So be very, very careful on this. We're going to say -3 to the 8th power. And -3 is inside parentheses. Don't let that mess you up. -1 all over -3 minus 1. All right, we're going to plug that in our calculator. We're going to plug it in just the way we wrote it. Alpha y equals -2, parenthesis, parenthesis, -3 parenthesis to the 8th power, minus 1. On the bottom, we're putting -3 minus 1. We got 3,280. Now, I want to do this the same way, but I want to use the other formula. -2 times 1 minus -3 to the 8th power, all over -3 minus 1. So, alpha y equals -2 times 1 minus parenthesis -3 to the 8th power over -3 minus 1. Oh, I missed a negative. Where did I miss my negative? Wait, where did I miss my negative? -2 minus -3. Oh, I know what I did wrong. Did y'all catch what I did wrong? What did I do wrong down here? Delete, 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 delete. This was supposed to be 1 minus. So, this was supposed to be 1 minus, and then r, which is -3. So, 1 minus -3. There we go. 3,280. Now, if you didn't get that, remember this. If you say -3 to the 8th power, or if you say -3 to the 8th power, do you see the difference in that? This right here says take 3, multiply it to the 8th power, and when you're done, make it a negative, which is what it did. This says take -3 and multiply it 8 times. Your calculator sees a difference. If you need help with this right here, come see me. All right. So, geometric series, it's the same thing as the other one. It's a series of the terms in a sequence. So it's just a series of the terms in a sequence. Okay, same thing. All right, so let's just get to some examples. We're just going to crank through these. All right, a geometric sequence has a first term of, and I wrote this wrong here on your paper. So this should say of 81 and a fourth term equal to 3. I don't think I got that corrected on my notes when I first did these. Find the common ratio and the general rule. So we've got a first term of 81 and a fourth term of 3. And we don't know the common ratio. But we do know this. We know the common rule. Oh, did I give you the rule up there? I sure didn't. Let's go back up here. I need to give you the rule. For geometric sequence, the rule is U sub n equals U sub 1 times the common ratio to the n minus 1 power. That is our rule. We're going to be using that again. This is all in your formula chart, which hopefully by now I've already given to you to have to kind of be looking at. All right, so U sub n equals U sub 1 times r to the n minus 1 power. What I do know is that U4 is 3. U4 is 3. So I'm going to say u4 is 3, which is u sub 1. Oh, and I know u sub 1 too, don't I? U sub 1 is 81 times r, and I'm doing u4, so that would be 4 minus 1. Now I want to make sure you understand what I did there. I took u sub n, and I'm calling it u sub 4. U sub 4, which is 3, equals u1, which is 81, times r to the n minus 1. But I'm doing u4, so that means this is 4. I'm going to simplify this, and it should give me what r is. So we're going to divide both sides by 81. 3 divided by 81 is going to be 1 over 27 equals r. 4 minus 1 is 3. R to the third power is 1 over 27. I need to take the cube root of each side. The cube root of 1 over 27 would be 1/3 equals r. Okay, so now I know r. I know the first term. Find the common ratio, which we did, and the general rule. So the general rule is going to be u1 times 1/3 to the n minus 1 power. All right, moving on. Example 13. Where are we at? All right. Let me find my example 13. I think it's on a different page. Show that the sequence with 3 consecutive terms. There it is. That is. Oh, my pages were out of order. All right. Show that the sequence with 3 consecutive terms, 75, 375, 1875, is geometric. I need to know consecutive because that's the only way to find the common ratio. So remember, if they are geometric, and we want to show this, the common ratio would be take the second term, 375, divided by the first term, and that should equal the third term, which is 1875, divided by the term in front of it. And when we do that, you actually get 5. So that means the common ratio is 5, and that means it's geometric. All right. A geometric sequence has a second term of 14, and a sixth term of 224. Find r and find the first term. All right, what do we know? We know this. U sub 1 times r to the n minus 1. We could use u2 to help us. So u sub 2 would be u sub 1 times r to the 2 minus 1, right? U sub 2 is 14 equals u sub 1 times r to the first power. And then let's do u sub 6. So let's come over here and let's do u sub 6 would be u sub 1 times r to the 6 minus 1. And since I know 6, I could say 224 equals u sub 1 times r to the 5th. I'm going to put parentheses around that. Okay, well, what if I, couple of different, I'm thinking one is, could I solve each of these for u1 and then set them equal to each other? I could also think about, okay, well, geometric is proportional, so I could have ratios. I wonder if it would be easier to do something like this. And remember, I'm kind of brainstorming here. There's a lot of different ways. What if I just said this? Would you agree with that? U2 over U6 equals U2 over U, right? It would equal the same thing. So this is U6 and this is U2, right? Let's see. I don't want to write that. I'm kind of thinking like Okay, well, here, let's just do this. Let's do 14 over 224. That would be this one. Equals, and I'm going to do this. I'm going to say, I'm going to go right here. U2 right here, this U2 and this U2, they're the same. This would be U1 times R to the first power over U6. I'm going to go here, and this would be U1 times R to the fifth. I really didn't use these much. I mean, I kind of did in a way. But now I have a proportion. And if you remember how to cross multiply, I wonder if this would help. Well, first off, you know what I noticed? When I do that, the U's cancel out. R would cancel out here, leaving me 1. And this R would become R to the fourth. Okay, let's cross multiply. So that'd be 14R to the fourth equals 224. Let's divide both sides by 14. Let's see what happens here. So R to the fourth would be 16. Oh, okay. If I were to take the fourth root of both sides, here's the catch. When you take a root that's an even, it has to be positive or negative. So that means R could be positive or negative 2. I just don't know which one it is. So because of that, I'm going to have 2 scenarios. One where R is positive 2 and one where R is negative 2. So I'm going to have R equals 2 and R equals negative 2. Both are correct answers. So there's just 2 different answers on this. So it wanted me to find R. Okay, here's R and the first term. So I need to find U sub 1. So I was looking at kind of some of the things I did. So let me go here. Let's use U2. So this would be 14 equals U1 times, and this was if R is 2 to the first power. I'm going back up here to this U2 one where I already plugged it in. So I would divide both sides by 2, and this would give me that U1 equals 7. Okay, so in this scenario, U1 is 7 and R is, I'm going to write it backwards since I wrote the U backwards. So there's that one. If R is negative 2, I'm going to use that same equation. 14 equals U1 times negative 2 to the first power. Divide both sides by negative 2. Negative 7 equals U1. And my R equals negative 2. Both of them are the right answers. Just 2 different scenarios. Geometric, we might get some where we don't just have one answer like we did on arithmetic. Geometric can be a little cantankerous. All right. Let's look down here, number 15. Find the sum of the first 8 digits of the geometric sequence. All right, so let's go back and let's remember the formula for sum. So remember we took U sub 1 times R to the nth power minus 1 over R minus 1. We can use either one. We could do it both ways. On this one, though, I guess I need to figure out, I need to know my U sub 1. So let's come here. U sub 1 would be 24 over 5 times negative 5 over 2 to the first power. Okay, so U sub 1 equals 24 over 5. I'm going to work that out, and I got negative 12. Okay, so here's U1. Can I see my R? Do I know what R is? R equals, it's this number right in here. So negative 5 over 2. If you didn't see that, what if you're like, well, I don't know what R is? Remember, you could have come over here and you could have found U2. And you could have done 24 over 5 times negative 5 over 2 to the second. And whatever that happens to be. So alpha y equals 24 over 5 times alpha y equals negative 5 over 2. This comes out to be 30. Then, remember, you would say, okay, well, if I was putting my blanks, the first term was negative 12, the second term was 30. So R would be 30 over negative 12. Oh, yeah, 5 goes into that, oh, not 5, 6. 6 goes into that 5, 6 goes into that 2, and it would be a negative. And then you could find it that way. But hopefully you can see that it's just right there. So here's the information I need to do my sum. So the sum of the first 8 digits is going to be negative 12 times, and I'm going to have to plug in the common ratio. Now it's not pretty. Negative 5 over 2 to the 8th power minus 1 over negative 5 over 2 minus 1. So we're going to do this in our calculator together. Alpha y equals negative 12 parenthesis alpha y equals 5, let's put negative 5, negative 5 over 2. Then you're going to move out, put your parenthesis, house top 8. And then we're going to do minus 1. And then we're going to do another parenthesis. On the bottom, we're going to do alpha y equals, and we're going to do negative 5 over 2 minus 1. Okay, now I got some crazy number, right? I don't want to put that on my test. I want this number to be a decimal. So I'm going to hit math, go down to decimal, hit enter, and here it is. So S sub 8 equals 5228.15625. Again, I'm not going to put that as my answer. I'm going to say S sub 8 equals 5230. Why in the world would I put that as my answer? Well, I'm looking at those sig figs. 1, 2, 3. The 8 would round the 2 to a 3. If you put 167301 over 32, that is absolutely fine too. If you're working them on Cognity, it'll tell you that it wants a decimal or sig figs or rounded. It'll tell you. So anyway, so you should be good there. All right, page 13. Number 16. All right, the sum of the first 10 terms of a geometric sequence is 1364, and 2 consecutive terms are 32 and negative 64. Calculate u sub 1. So let's write what we know. We know that the sum of the first 10 terms is 1,364. And we know, what do we know? We just know 2 consecutive terms. We don't know where they fall. We just know they're consecutive. So we'll put dots this way and we'll put dots this way. Just so we don't know where those are, but we know they're consecutive. Why do they need to tell us they're consecutive? Just so we can find the common ratio. So the common ratio would be negative 64 over 32. I'm going to simplify that and get negative 2. So I know that negative 2 is the common ratio. I don't exactly know the first term though, right? But here's what I know. S sub n equals u sub 1. Oh, there goes my washer again. It's a haunted washer. There we go. I'm going to plug in values that I know. I know this. I know R. And do I know the N? Yeah, the N is 10. So I also know that. I know everything except u sub 1. This is just algebra. All right, so we're going to say 1,364 equals u sub 1 times negative 2 to the 10th power minus 1 all over negative 2 minus 1. All right, negative 2 minus 1 is going to give me negative 3. So I'm going to go ahead and change that to negative 3. I'm going to multiply both sides by negative 3 to get rid of the denominator. Negative 3 times this is negative 4,000 192 equals u sub 1 times negative 2 to the 10th power. So let's remember, that calculator is picky about this. Negative 2 to the 10th power. 1024. And then I need to subtract 1 from it. So it's 1023. So this is 1023. So u sub 1 equals, I'm going to divide both sides by that, and I got negative 4. The question just wanted me to calculate that. There we go, u sub 1. All right, the general term of a sequence is given by that. Determine if this is geometric. Well, if it's geometric, I probably just need to do u sub 1, u sub 2, u sub 3, etc. So here we go. So u sub n equals 5 times 3 minus 4n. All right, let's figure out u sub 1, u sub 2, u sub 3. If we can do these three, then we'll probably be pretty good. Now, in my opinion, the easiest way to do it would probably be to put this in my calculator, work it out that way. But we'll do it this way. 5 times, oh my goodness, my haunted dryer washer. Okay, this is 4 times 1. So this would be 5, let's see, 3 minus 4. This would be 5 to the negative 1. This would be 5 times 3 minus 4 times 2. So that would be 5 to, let's see, 3 minus 8. So that would be negative 5. This would be 5 to the 3 minus 4 times 3. Right, 12, 3, so that would be 5 to the negative, am I doing that right? 3 minus 12, yeah, 8, 9, yeah. Okay, I think I'm going to go one more step. I'm going to actually see 5 to the negative 1. So let's do 5 housetop negative 1. I'd almost rather work with decimals than that. 5 housetop negative 5. 3.2 times 10 to the negative 4. 5 housetop negative 9. 5.12 times 10 to the negative 7. Okay, well, remember we've got to set up that common ratio. So we need to take u2 divided by u1 has to equal u3 divided by u2. If I lost you there, remember it's u1, u2, u3. And the common ratio is to take this one and divide it by the one before it. Take this one, divide it by the one before it. So I just set it up there. So here's what I'm going to have. Let's see. u2. Okay, we can do it one of two ways. You can either use this or this. I'm going to use this. Doesn't matter to me. You might like to use this right here. It might be easier. I'm going to say 3.2 times 10 to the negative 4th over 0.2. Let's see what that equals. Let's just do that one right there. 3.2 times 10 to the negative 4 over 0.2. Okay, that is 0.016. Okay, so there's that common ratio. Now let's do the next one. Let's do the third one. So I'm going to do 5.12 times 10 to the negative 7 over the term before it, which is 3.2 times 10 to the negative 4th. Alpha y equals 5.12 times 10 to the negative 7 over 3.2 times 10 to the negative 4. Oh, looky there. 0.0016 again. I should have put my 0 there. Okay, so they have the same common ratio. So the common ratio is 0.0016, therefore geometric. All right, given that the sequence x minus 1, x plus 2, 3x is geometric, find the possible values of x and r. Okay, so I'm going to come over here and say u1 is x minus 1, u2 is x plus 2, u3 is 3x. If it's geometric, I know what? There's a common ratio. And if there's a common ratio, I should be able to set it up just like we did that one over there. So remember, this would be x minus 1. Oh, I should have put that on top. Hold on. Let me fix that. Here's my terms. This would be x minus 1. This would be x plus 2. And this would be 3x. So I'm going to set up those ratios. I'm going to say x plus, I think my pen's done, over x minus 1 equals 3x over x plus 2. I'm going to have to cross multiply. Okay, here we go. When I cross multiply, I'm going to have x plus 2 times x plus 2 equals 3x times x minus 1. All right. I'm feeling the polynomial solver coming on. Okay, so let's distribute all this. So this would be x squared plus 2x plus 2x plus 4 equals 3x squared minus 3x. Let's get everything on the same side. So this would be x squared plus 4x plus 4. I'm going to move these over here. So that would be minus 3x squared plus 3x equals 0. I'm going to put my like terms together. So that would be negative 2x squared. I'm going to mark them off. This would be 3 and 4 would give me plus 7x. And that would give me plus 4 equals 0. I'm going to go to my polynomial solver. I'm going to go to apps. I'm going to go all the way down to number 9. Polynomial solver, second degree. Here we go. Negative 2, enter, enter. 7, enter, enter. 4, enter, enter. I'm going to solve it. So I get x equals negative 1/2 and x equals 4. So because it's geometric, it could be either one. Two scenarios. So I'm going to have x equals negative 1/2. If x is negative 1/2, can we find the first term? We can. So we're going to have x minus 1. So u sub 1 would be negative 1/2 minus 1, which is negative 3 over 2. So in this scenario, x is negative 1/2 and u1 is negative 3 over 2. But we also need to find the common ratio. Is that right? Yeah, we got to find, oh, I guess I should have done it down here. Okay, let's do this. I'm going to move that. I don't want to put that there. Don't worry if you did. It's all. So now let's just do u2. In order to find a common ratio, we got to have two consecutive terms. So this would be negative 1/2 plus 2, which is positive 3 over 2, right? I could do u3 if I wanted to, but I don't really want to. So in this scenario, find x. I don't really need that. What would the common ratio be? Negative 3 over 2 positive 3 over 2 divided by negative 3 over 2. The common ratio will be positive 3 over 2 over negative 3 over 2. Do you see how that's just going to be negative 1? And in this scenario, x is negative 1/2. Okay, so that's scenario number 1. I didn't leave myself much room, did I? Now we need to do what happens if x equals 4. So if x equals 4, u sub 1 would be 4 minus 1, which is 3. U sub 2 would be 4 plus 2, which is 6. And in this, the common ratio would be 6 over 3, which is 2. So in this scenario, x equals 4, and the common ratio is 2. Two different scenarios, two different answers. All right, how are we doing? We are done with the notes on geometric. Hopefully you're enjoying geometric. And we're going to do the check for understanding next.